This lesson is a continuation of the trigonometry lesson. In particular, we're going to be looking at how to answer using exact values. Let's take a square. Square has a right angle, and a square has all four of the sides being the same length. So let's call our side length x, and all four sides are the same. We could have a diagonal, as outlined with this blue line here. We don't really know the length of this diagonal, but we can find it. And we also have some angles. So we're taking half of this square, so we're only considering this bottom triangle here, which is formed from the square. So what do we know about our angle? Well, squares have 90-degree angles, so halfway through should be 45 degrees. And so should this be 45 degrees. Now, can we find this diagonal? Let's call it C. Yes, it's a right angle triangle, so we can use the Pythagorean theorem to inform us that x squared plus x squared should equal c squared. Let's find a way of writing c by itself. So if we add these together, this gives us 2x squared equals c squared. And therefore, if we root both sides, we get c to be root 2 times x, which can also be written as x root 2. So what that means is that no matter what, if we have a triangle, a right triangle, with degrees 45 in the interior angles, then say you had a size 5 and 5, then you'd know that the diagonal has to be 5 times root 2. If these sides were 10 each, then this would be 10, 10, 10 root 2. So it shows you a proportion that can be used, and this gives us our first special triangle. The second special triangle can be created by taking half of an equilateral triangle. Now, what do we know about an equilateral triangle? We know all three sides are equal, and therefore we also know all three angles are equal. So what are they? Well, in total, we have 180 degrees in a triangle. If we divide that equally among three angles, we would have angles of 60 degrees. So that tells us this would be 60 degrees. Now, if we slice the equilateral triangle in half, then we'll have half of this angle, which is 30 degrees. In terms of the sides, we know that all three of these orange sides are the same. So let's call one of those x, but then we'll have half x here, and I'd like to avoid fractions. So let's call this half a side x, and then call the total side 2x. If we do that, let's find this blue side c so that we form our special triangle. We can again use the Pythagorean theorem. So we know that x squared plus c squared should give us 2x squared. Let's get c squared by itself. So that's going to be c squared equals 4x squared minus x squared, and we just evaluated the 2x squared to become 4x squared. So that gives us c squared is equal to 3x squared. Therefore, if we root both sides, we get c equal to x root 3. So that gives us a new set of proportions for any 30, 60, 90 triangle, and that's our second special triangle. Let's see how we can use these triangles, shown above, to find the exact values of the following. Let's first start with cos of 45. So as soon as you see 45 or 30 or 60, you know you can find exact values using the special triangles. So because we have a 45, let's call up our 45-degree special triangle, which is made from half a square. And we want to find the cosine. So, for example, one instance of this would be 1, 1 root 2. Another could be 2, 2, 2 root 2, or 5, 5, 5 root 2. Either way, we'll have the same proportions when we divide. So you could also use x here if you wanted to, but you'll notice it'll cancel out. So try it a few different ways and see if you get the same proportions. Cosine, from our mnemonic SOHCAHTOA, relates the adjacent and the hypotenuse. So if 45 is our reference angle, then we have our adjacent being 1 and our hypotenuse being root 2. So if we take our adjacent 1 over hypotenuse root 2, that would be the exact value for cosine of 45. Now you can check that on your calculator, type in cos 45, and then type in 1 over root 2 and see if they're actually the same. You'll find that they are. But 1 over root 2 is a more precise way, a more exact way of writing it. However, we need to remember that we cannot leave any roots in the denominator. So that would mean we would have to multiply by root 2 to get it out of the denominator, which gives us root 2 over 2. Let's try the next example, sine of 30. So in this case, because we have 30 degrees, we want to use our second special triangle, which is a 30, 60, 90 triangle with root 3 to 2 to 1 ratios. Each of these could have an x because they could be multiplied by any number by dragging and scaling the triangle. However, remember when you take the fraction, the ratios will remain the same no matter what you had multiplied these by. Comes from the fact that you can multiply any fraction by anything. You could multiply this by x, and it'd still be the same thing, but then it would cancel out. So sine of 30, 30 is our reference angle, and sine relates opposite and hypotenuse, meaning we would have our opposite being 1 and our hypotenuse being 2. So that would mean that sine 30 should be 1 over 2. Hey, didn't we look at sine 30 in the previous lesson and it gave us 0.5? Well, there you go. That's exactly why. Next, let's look at tan of 60. So if we had to find tan of 60, so now we're looking at this 30, 60, 90 triangle, but considering the 60 as the reference. So your labeling changes. So you got your opposite, adjacent, and hypotenuse like this time. But the ratios remain the same, root 3 to 2 to 1. So 60 for tan will give us opposite over adjacent, which is root 3 over 1, which is just root 3. So we are able to find exact values only for angles used in the special triangles that we have developed. Further, you could use the triangles again to find the exact values of all the unknown sides in the following triangles. So here we have a 45-degree triangle, so we're relating it to our half square, 45, 45, 1, 1, root 2. So remember that these could all be multiplied by any scale factor and it would still be the same proportion. So in this case, this one is 5. So rather than having a 1, we could multiply all of these by 5 so that this side is 5. So then we'll have 5, 5, and 5 root 2. And we're done. We filled in all the missing sides. We can also fill in the angles. We know that the other one has to be 45 if this one was 45 by properties of 180 degrees in total. Next triangle, we have a 30-degree triangle. So it's nice to be able to know your special triangles well enough to rotate them around also. But if you imagine it as being half of an equilateral triangle, you can better remember them. So if this part was 30, that was the half part, and this was 60. So remember, this was like 1:2 ratio because this was half of the side of the triangle. And this side here, through the Pythagorean theorem, came up to be √3. So now we know we can multiply any of these by anything to serve us for what we need. In this case, we want this side to be 7, so we would multiply it by 7 to get there. So let's multiply everything by 7 because it will stay in a proportion if you do so. So that would give us 14 and 7√3. So we can find exact values by using the special triangles, and exact values are only going to work for you if you have angles of 30, 60, or 45.